All right, welcome back, everybody. We are taking this three-variable, three-equation system. We're going to solve it for x, y, z, the ordered triple, but we're going to do it using a matrix, a 3x4 augmented matrix. And the process we're going to use is Gaussian elimination, and we're going to get the matrix into row echelon form so we can then back substitute in to find what the x, y, and z are. And we have a plan up here, we said. We're going to try to get it to look like this. And we're going to do it in that order. And we got our first task of the 1 already done. We are now going to try to get a 0 where the negative 1 is and a 0 where the 2 is. And I'm actually going to do it in the same iteration, the same matrix. I'm leaving 1 alone. Matter of fact, I'm never touching 1 because 1 has the 1 where I want it and I don't care about the other numbers. All right, so I'm going to take row 2 and add it to row 1. Negative 1 plus 1 is 0. 3 plus negative 2 is 1. 0 plus 3 is 3. Negative 4 plus 9 is 5. Not only did it get me the 0 where I wanted it in row 2, column 1, it also got me a 1 in row 2, column 2. What a great move. So I got 3 pieces in place. And now I'm going to also get rid of this 2. And by that, I'm going to, well, I bet you have 2 thoughts. I'm going to subtract 2 row 1s. I could have also added 2 row 2s. So row 3 minus 2 row 1s. 2 minus 2 is 0. Negative 5 plus 4, right? Because negative 2 times negative 2 is plus 4. Negative 5 plus 4 is negative 1. 5 minus 6 is negative 1. 17 minus 18 is negative 1. Just happens that we have a whole lot of negative 1s there. All right, so if we go back to our goal, our row echelon form matrix, we've got our 1 there. We've got our 0 there. We've got our 1 there. We need the last 3. So let's see. Pardon me, we got another one too. We got that 0. My bad. So I want to get a 0 here, and I want to get a 1 there. So how I'm going to, a new iteration, again, let's use our words. I want to leave row 1 alone. I'm going to leave row 2 alone because it's exactly like I want it to be. A 0 and then a 1. And to get row 3, the 0 right here, I'm going to take row 3 and add it to row 2. 0 plus 0 is 0. Negative 1 plus 1 is 0. Negative 1 plus 3 is 2. Negative 1 plus 5 is 4. I'm almost home. I got this 0 here now. I got one more number to get, which is our last one. And when you have 2 zeros is the only time you multiply. Because otherwise you could be introducing fractions, which could get messy. All right, so what am I going to do? Again, I'm leaving this row alone. I'm leaving this row alone. And I'm taking row 3 and taking half of it. Divided by 2. 0 divided by anything is 0. 2 divided by 2 or times a half is 1. 4 divided by 2 is 2. I now have my matrix in row echelon form, so I'm going to reintroduce variables so I can finish solving. X minus 2y plus 3z equals 9. Y plus 3z equals 5. Z equals 2. I know you can do this because we did this at the start of our lesson on day 2. Back substitute. Y plus 6 equals 5. Y equals negative 1. And back substitute a third time. X minus 2 times negative 1 plus 3 times 2 equals 9. A little mental arithmetic. X plus 2 and a plus 6 is plus 8 equals 9. X equals 1. Write it as an ordered triple. X is 1. Y is negative 1. Z is 2. What could I do with that ordered triple? I could plug it back into any of the 3 original equations, and they would work every single time. What else is it? It's the intersection of the three planes in space where they intersect. All right, so lots of new terms. We're done for day 2. We took this 3-variable system, made a matrix out of it, an augmented 3x4 matrix. We used the process of Gaussian elimination and row operations to get it into row echelon form, which then by back substitution allowed us to solve for the order triple 1, -2, 2. All right, guys, great work today. Day 2 is over. Hope it makes some sense. And again, answers are secondary. Process is everything. If you have to look at this a couple times, no problem. Have a great day. We'll see you.